So let's talk about conditionals. And we said last time conditionals are if-then statements. All right? So, and we actually start talking about one. We said if, let's see, John went to the library, using the example we did last week. Then he is studying. All right. So, if John went to the library, then he is studying. Let me just ask you to think about that statement for a second. If you were to walk to the library, if you see John in the library, what can you conclude?
He's reading.
Well, he's studying, right?
Oh, yeah, he's studying.
You can conclude that because this tells you if he's there, then this is what he's doing. If you see John studying, does that mean he's at the library?
Yeah.
No. All right? That's very rumbly. All right. He could be studying somewhere else. This doesn't tell you that he's only studying in the library. It just says if he is at the library, then that's what he's doing there. He's studying. All right. So an if-then statement goes one direction, not the other way. All right. All right. So how do we symbolize this? Well, if we use this, the letter A to symbolize John went to the library, and B to symbolize he is studying, then it is A, sideways horseshoe, B. All right? This means if A, then B. If John went to the library, then he is studying. All right? All right, now, we also have terms for each of these, the A and B. All right, yes?
What does the symbol mean?
I'm sorry?
What does the symbol mean?
The symbol means if then.
If then?
Yeah, you put it in between, well, what's called your antecedent and your consequent. Hold on, I'll get out of your way in a second. The if statement is called your antecedent. Yes. And your then statement is called your consequent. Does that sound like another word? Consequent? Consequence, right? That's the then. All right, helps you keep it straight. Consequent sounds like consequence. Consequence is something that's a result, right? So the then statement is the consequent. Antecedent is the if statement. Consequent is the then statement. You put your antecedent first, then your sideways horseshoe, then your consequent. All right? You got that so far? Yeah.
The B be a C then, if it's a consequent?
I'm sorry, wouldn't what?
Would the B be a C? Because it's a
Not this. I'm just symbolizing this statement. If John went to the library, then he is studying. A represents, if you take out the if and the then, all right, A basically represents John went to the library. B represents he is studying. And so the operator symbolizes the if and the then. Make sense?
Yeah.
Okay. All right. Now, what else did I want to tell you here? Yeah, you don't need to know that. All right, so that's our operators, that's our conditionals. Now let's put together a logical argument, shall we? Yay. Can I erase? All right, I'm erasing. All right, so let's put together an argument. Now, an argument is made up of premises and a conclusion, all right? Premises are kind of like your givens. I'm telling you certain things are true, and then you're going to use the laws of logic to figure out what you can conclude if those things are true, all right? Your premises they can be just flat out propositions. They can be propositions that are linked with other propositions by operators, whatever. For example, let's say I go premise 1, all right? My premise 1 is this. Somebody tell me what that means? By show of hands. If A, then B, that is correct. Premise 2 is this. It's just A, all right? I'm giving you the proposition. I'm telling you the proposition A is true. Now, here's how you write therefore, in case anybody wants to know how we abbreviate therefore. It's 3 dots kind of in a triangle. That symbol means therefore. All right, so you see that on your worksheet as well. So you tell me, you have as premise 1, if A then B. Premise 2 is A. What can you conclude? Give me a hand. B. Because notice, premise 1 didn't tell us that A was true. It just says if A is true, then B is also true. Then we get to premise 2, and premise 2 tells us that A is true. So now you take this and you apply it to this and you realize, oh, then that means B must also be true. That's your conclusion. Do you see how that works? That is a logical argument. You're shaking your head. What, is there something you don't understand? I'm sorry? The whole thing. Okay. Let's spell this out a little bit easier. Okay. What's your favorite flavor of ice cream? Vanilla? Okay. So let's put a statement together that we say, if buying ice cream, then it's vanilla flavored. Okay. In other words, if you're going to buy ice cream, then it's vanilla flavored. All right. Now that's our first statement. Our second statement: somebody walks up to you, or let's say walks up to and say, "Hey, guess what? I just saw with ice cream." Well, if he knows that first statement, will he know what flavor you've got? Yes, because we just said if you have ice cream, then we know it's vanilla. All right. Now it gives us that piece of information. Well, you have ice cream, therefore we know it must be vanilla.
How do they know?
How do they know she got it again?
They have to go based on.
It's if we have that first statement. All right. If you.
How do you know that, that person?
Like, what if she wanted to try something new?
Yeah.
Then that first statement wouldn't be true. I'm telling you, remember, all that logical arguments do, and we'll talk about this a little bit later on, is it's what can you conclude if both of these statements are true. Everything you're saying right now is challenging whether this first statement is true. And that is a way you attack people's arguments. Because sometimes people will make an argument and you'll go back and say, well, wait a minute, whatever your premise 1 was just isn't true. So maybe, let's say, for example, you were to ask me and say, apply this to me and says, well, if Mr. Kaufman got ice cream, then it would be vanilla. Well, Mr. Kaufman has ice cream, therefore it's vanilla. Well, that's great, and that's what we call a valid argument. In other words, the structure is good, but it's not a sound argument. Because anybody that knows me knows that vanilla is not my flavor of ice cream. Matter of fact, if I have ice cream, does my daughter know what flavor it would be?
Mint chocolate chip.
Mint chocolate chip, that is right. Again, I'm not subtle in any area of life. I love mint chocolate chip ice cream. So, yes, you can challenge whether, it's called the soundness of an argument. Again, we'll talk about that a little bit later, by challenging whether the premises are actually true. But for the way logic works and what we're trying to train is if these premises are true, what can we conclude from them? So if we agree that it is true, it is correct, that if it has ice cream, then it is vanilla. And then we learn that it has ice cream, then we conclude it must be vanilla. Because that first statement, if we're assuming that first statement is true. All right, yes.
What if it is true, but it doesn't happen?
That's what the second premise did. It did happen. Remember, we're assuming that she does have ice cream. It's assuming these statements are true. What can you conclude?
Assuming.
Yes, that's the way logic works. All right, all right. Yes, you got a question? Shh. I called on.
What if for premises 1 it was if A then B, but for premises 2 it had like that squiggly mark and then like the.
I know. No. We're gonna get to that. I'm on to you. You're trying to get me to answer one of the questions on the worksheet. We're not there yet. So what we need to do, we're gonna run through what are called rules of inference. All right. Rules of inference. All right. These are the rules you can apply to premises to legitimately draw conclusions. All right. What we just did here, all right, is one of those rules of inference. It is actually called, you ready for this?
Inference.
No. It is called modus ponens. I know. And then they name something. Wait till you see the next one. They name something very similar to make it almost impossible to remember. But here's the thing. Modus ponens is affirming the antecedent. Which term is the antecedent? The first one or the second one up here? The A, right. The first one, the if statement is the antecedent. And what does affirming mean? Means true, right? So, according to modus ponens, if you have an if-then statement, and then you say the antecedent is true, you can legitimately conclude that the consequent is true. All right? This, what we just did, is modus ponens. All right. Do we have modus ponens?
No.
All right, let me know when you got that written down.
Oh, got it.
Now, we're going to learn modus tollens. Oh my gosh! Believe me, I had the same reaction. All right? This is basically the exact opposite of what we just did. Denying the consequent. Which one is the consequent?
The B.
The B. And denying means what?
It's not true.
It's not true. So now our premise 2 is not B.
Wait, what
C.
did that say?
What?
Modus tollens. Tollens.
Oh.
Exactly. Modus tollens means denying the consequent. All right. So not B. So, anybody want to hazard a guess? What we can conclude, if we have if A then B, not B, what can you conclude? Not A. Think about our studying example. If John is at the library, then he is studying. Premise 2, John is not studying, which tells you what? Then he ain't at the library, is he? Because if he wasn't at the library, he'd have to be studying based on the first statement.
I mean, this would not.
If the first statement is true, all right? Again, you guys, you got to get past for now. We'll deal with this when we get to actual arguments. Get past for now whether or not these premises are true. I'm requiring you, for the purposes of our symbolic logic lessons, to assume everything I tell you in a premise is true. All right? Because that's all we're doing. We're following how reasoning works. All right? So if it is true that if John went to the library, then he's studying, and you find out he's not studying, then he must not be at the library. All right? That is modus tollens, denying the consequent. All right. Let me know when you got it. What part are you struggling with? Oh, you're still looking at the worksheet. Well, I'm not giving you all. Matter of fact, you're going to hate me here a little bit. That last problem on the worksheet, we're not explicitly reviewing in class. That's to see if you can figure it out based on everything else we talked about in class. Next one is going to be called a hypothetical syllogism.
What?
Yeah, exactly. Because philosophers like to make things sound fancy. Syllogism is just another word for an argument. That's all it is. But we can't just say hypothetical argument. They want to say hypothetical syllogism because it makes them sound better, and they spent a lot of money getting their PhDs, so they have to sound smart. Okay? What's that?
It's a combination of 3 letters.
All right.
Oh my.
He speaks the truth.
Here is how hypothetical syllogism works. Premise 1, if A, then B. Premise 2, if B, then C.
Big word. A and C.
If A, you say it's if A, then C. Exactly.
What?
You're just cutting out the B in the middle. If you take these two premises, this is basically like saying this. If A, then B, then C. It's just setting up a causal chain. All right? If it rains, then I'm going to get wet. And if I get wet, then I'm going to slip and fall on the stairs. All right? No, I am not the Wicked Witch of the West. All right? Think about it. If it rains, then I'm going to get wet. If I get wet, then I'm going to slip and fall on the stairs. Therefore, you conclude, if it rains, I'm going to slip and fall on the stairs.
Conclusion, you're gonna break all the bones in your body.
Thank you very much. Yes. All right? It's just cutting out the middle, basically. Do we get that one? Hypothetical syllogism. All right. Moving along. What time is it? It is not 2:03. All right. The law of non-contradiction. Yes.
What's the real definition of premise?
It's just write if A then B, if B then C, therefore if B then, or if A then C. It's basically just it's cutting out the middle of your causal chain. You know, if you want to, your hypothetical syllogism is that if A then B, if you're given if A then B, and then you're given if B then C, then you can conclude if A then C. That's what we're going to talk about next, the law of non-contradiction. All right. Remember, folks, also, if you need to review this, just because you're not here, you can also go back and watch the video. You already took a shot at it?
Is it due on Friday?
This is due on Friday, yes. Congratulations. Yes, you got it right. You got it right. I'm sorry? If you think you've got it, but hold on, folks. Let's get through the law of non-contradiction, all right? The law of non-contradiction says that two contradictory statements cannot both be true at the same time and in the same sense. If I were to do this symbolically, all right, it means not, and then we put a parenthesis, P and not P. That's the law of non-contradiction in symbolic form. What does that mean? Suppose you were at a party and you come across a young couple, young married couple, they're about 30 years old each, and you walk up to the husband, and you say, hey, I heard you guys are expecting a baby. The husband says, yes, we are, thank you. The wife says, no, we're not. I am not pregnant. Can they both be telling the truth? No. But then they're not both telling the truth. In other words, one of their statements has to be false. Yes, Ms. Coughlin.
What if they are expecting a baby, but they're adopting, so she's not pregnant?
Okay, let me rephrase. Thank you. You're so my daughter. How about instead the man walks up, guy walks up, so I hear that your wife is pregnant, and he says, yes, she is, and she says, no, I'm not. Better?
Maybe he's not the father.
I didn't. Okay. Did I say that? The question is she pregnant? All right, folks, you are overthinking this. Is it possible for a woman to be both pregnant and not pregnant at the same time?
Yes.
No. All right. That is the law of non-contradiction. All right. They cannot both be true. The rules of inference I'm giving you are the ones that we see most often come up in apologetic circles, in apologetic arguments. All right? Now, we're going to close today trying to hit a few logical fallacies. I'm sorry? It is the reasoning is very similar to what you do in math. Thank you very much. All right. In the last few minutes we have, we're going to talk about a few logical fallacies. This is extremely important for what we're going to be doing in the rest of the unit, because you are going to be looking at various different arguments. We are going to look at arguments in favor of the existence of God. We are going to look at arguments, at least one argument that claims to be against the existence of God. And we're going to talk about whether they are valid or sound. Now, valid argument. A valid argument, all right, is one in which the form of the argument is correct, is true, all right? For example, if A then B is premise 1, the same argument we talked about, premise 2, A, conclusion, therefore B. That argument, that is a valid argument form. All right, that's modus ponens. We talked about that. So no matter what I put in these terms to fill them in, the argument is valid. Yes?
What are there like 3 dots to like represent it?
But therefore, I don't know, because it is. That's the therefore symbol. I don't know where it came from.
So, because it's like, what if the song was switched around? Like A, like.
Hear me out. That is a valid argument form no matter what I put in those slots. So if I say, for example, all dogs are amphibians.
What is that? That is not true.
Fido is a dog.
You just said it's a reptile.
Based on modus ponens,
Technically.
what can you conclude from these two premises?
He's a.
Fido is an amphibian.
Fido is an amphibian.
Oh.
All right, hold on.
Who's Fido? The dog. The dog.
All right. That argument is valid. Valid means it follows the proper form. That is in this form, right? But it is not sound. A valid argument is one that has a proper argument form. A sound argument is one that not only has a proper argument form, so it's not only valid, but also all of its premises are true. Are all dogs amphibians? No.
No dogs are amphibians.
Correct. That is a valid argument because its form is correct. It is not a sound argument because its premises are not true. If I change this to mammals, we change our conclusion to mammal. Now it's sound. Now it is both valid and sound. Do you understand the difference between those?